Welcome everyone to the next lecture of quantum gates. So in previous lecture we have seen what is a Pauli X gate, what is a Pauli Z gate and what is a Pauli Y gate. So we have seen that what the X gate does, it works same as a NOT gate. If we are giving the input as a gate 0, we are getting the output as a gate 1. If we are getting giving the input as a gate 1, then we are getting output as a gate 0, right? Then we have seen the Y gate. So what Y gate does, when we are giving the input as a gate 0, we are getting output as a I into gate 1. So it shifts the phase. Then we have seen when we are giving the input to the Y gate as a gate 1, we are getting output as a minus I gate 0. Right? It shifts the phase. Right? Then we have seen the poly Z gate. What poly Z gate does? When we are giving the input to the Z gate as a gate 0, we are getting the output as a gate 0. And when we are giving the input to the Z gate as a gate 1, we are getting the output as a minus gate 1. Right? So this all the gates we have discussed. Then we have seen the mathematical representation of these all gates. Now we will see these gates practically. So when I'm telling that it shifts the phase, so how it works, that we will see practically on the IBM composer. So this is a IBM composer. This you can see on the website quantum.ibm.com composer. Okay, so this is a composer which help us to understand the quantum circuits and quantum gates. So as we have seen Pauli X gate. So Pauli X gate is denoted by this symbol here. So what I have done, this input, what is this? Qubit 0. Input is gate 0. Firstly, understand how this qubit 0. Suppose I am applying the measurement over here. So see, if I am applying the measurement over here, what is the input? What is it? Gate 0. So the state vector is 0. Probability of getting the vector is 0 because we are giving the input as a 0 only. Now when I am applying the poly X gate on a 0, what is the expected output? Expected output is a gate 1. So you can see I am getting the output as a gate 1. Now see, here also I am getting the values of output as a 0 plus 0 j comma 1 plus 0j. What it means? It is a matrix form of 0 1. So 0 1 is denoted by the gate 1, right? So here I am getting the output as a 1. So I hope you have understand how the uh, poly X gate works. Now same thing I want to see on the Bloch sphere. Now see when this poly X gate is not there, so input is a gate 0. When I am applying this poly X gate over here, output is gate 1. Complete shift of pi is happening over here. So this is our output. Now we will see how the poly Y gate operates. Now input is gate 0. If I am applying poly Y gate over here, so it shifts the phase and also it changes the changes into the complex number. So you can see over here that this is a complex number 0 plus 1 j. So this is a complex number. So when we are applying the poly Y gate on the gate 0, we are getting a output as a we are getting the output as a I of 1, right? Then we will see how the poly Z gate operates. Suppose I am applying the poly Z gate over here. So what happens? See, As we know that when we are applying gate 0 to the poly Z gate, we are getting the output as a 0 only. So here you can see we are getting the output as a 0 only. So the equation didn't change. Now I want to see that when I am applying the gate 1, so what happens? Now see, firstly I need to convert this input as a 1. So to convert the input as a 1, I will apply NOT gate over here. So here I am getting 1. Now I will apply the Z gate. So I am getting the minus 1 plus 0j. Understood? So this is the practical representation of the gates, how gates are operating. I hope you have understood that how these gates are operated. Now we will move forward to our next gate. So next gate is Hadmard gate. Basically, this Hadmard gate is based on the Harmington matrix. Now, what is this Harmington matrix? So, this matrix is known as a Harmington matrix. Okay, so how this Harmington matrix work? Now, as I taught you previously, firstly find out the equation for this Hadmard gate. So, how to find out the equation for the Hadmard gate? Simply write like this: gate 0, gate 1, bra 0, bra 1, and here the matrix form 1 1 0 minus 1. Now see, gate 0 multiplied by bra 0, and this 1 is multiplied, so 1 is not written over here. Then plus, so this we got, then gate 0 multiplied by bra 1. This is 1 over here, sorry, this is also 1. So this is 1 over here, so gate 0 bra 1. Then gate 1 bra 0, gate 1 bra 0. This is a 1, then this is a minus, so gate 1 bra 1, gate 1 bra 1. This minus symbol, that is minus 1, comes over here. So like this you can form the equation for the matrix. So this equation you got. Now same as a poly X gate, we will operate gate 0 and gate 1 on the this Hadmard gate. So when I'm applying, now see, input is gate 0. So when I'm applying Hadmard gate on a gate 0, so what I need to do, I need to multiply the Hadmard gate matrix with the gate 0 matrix. So when I'm applying a Hadmard gate on the gate 0, I'm getting the answer as 1 by root 2 column matrix of 1 1. In equation format, it can be written as 1 by root 2 gate 0 plus gate 1, right? Have you seen this equation before? Yes, we have seen. What is this equation? It is the equation for the gate plus. As you can see on a block sphere, it lies on the x-axis. So then if we will reverse this, so if we will reverse this means when I am applying the Hadmard gate on the gate plus equation. So when I am applying the Hadmard gate on the gate plus equation, I am getting the output as a 1 0 column matrix of 1 0, which is nothing but the gate 0. So from this you can conclude that this operation is reversible, right? So this operation is reversible. Now next gate is S gate. Before going to the S gate, you find out, I will give one example and find out that, do the practice at home. That is, apply Hadmard gate on the gate 1. Simply write down the Hadmard gate over here, multiply it with the gate 1. What is the gate 1? 0 1. So you will get the equation 1 by root 2 gate 0 minus gate 1, which is the equation for the gate minus, right? So do this, perform this operation and let me know in a comment, are you able to calculate or not? Okay. So this is a Hadmard gate operation. When we are applying the Hadmard gate on a gate 0, we are getting a gate plus. And when we are applying the Hadmard gate on a gate minus, gate 1, we are getting the answer as a gate minus. Then next is a S gate. So what this S gate does? The matrix for the S gate is 1 0 0 I. So 1 0 0 I. It changes between the X and Z basis. So when we are applying the S gate on the gate plus, we are getting the answer as a gate plus I. And when we are applying the S gate on gate minus, we are getting answer as a minus I. Similarly, you can calculate the S gate on gate 0. So similarly, you can calculate apply S gate on gate 0. So answer for this is gate 0. And when I am going to apply S gate on gate 1, we are getting answer I of gate 1. So try to find out this two equations and let me know in a comment if you have any doubts. Okay, these are two single qubit gates which we are not discussed yesterday. So we will see the practical representation of practically we will see the practically how this Hadmard gate and S gate is operate. So we will go to the site of IBM. So now this is the input gate 0 when I am applying to Hadmard gate over here. See what I am getting. The amplitude of 0 is 0.707 and 1 is 0.707. 0.707 is nothing but the 1 by root 2. So matrix form of this is 1 by root 2, 1 by root 2 column matrix, right? So when I am applying the Hadmard gate on a gate 0, I am getting 1 by root 2, 1 by root 2. Similarly, if I want to apply the Hadmard gate on gate 1, what I will do, I will first convert 0 into the 1 using the NOT gate. Then I will apply the Hadmard gate over here. So what I will get, I am getting the 1 by root 2 minus 1 by root 2, which is the equation for the gate minus. I hope you understood this, right? Then we will see that S gate. So when I am applying the S gate on a gate 0, so I am getting the answer as a 1 0. 1 0 means gate 0, right? So I am getting the answer as a gate 0. Now I want to apply the gate 1 as an input to the S. So firstly I will convert this gate 0 into the gate 1. So output to this is gate 1. Now I am going to apply the S gate on a gate 1. What I am getting? I am getting the output as 0 plus 0j and 0 plus ij. That means the uh, I of gate 1. Understood? I hope you have understood this concept of single qubit gate. In next lecture, we will see the multiple qubit gate, how the multiple qubit gate operates. Thank you so much.